Good evening or good day everyone. So in this video we will be taking ourselves through how we can carry out transistor in the common base configuration. So transistor in common base configuration simply means the base terminal as shown in the circuit diagram below. The base terminal is common to both the input and the output section. So this is the base terminal, this is the input section, and this is the output section. So the input current is IE, the input voltage is VEB, the output current is IC, and the output voltage is VCB. So we want to look at how we can, now just like what we did in the common emitter configuration, we want to find the input parameters. We find IE and VEB at constant VCB. So when we are done with that, we find IC and VCB at constant IE. So it's just the same way, and we equally find the H parameters of the circuit. So the table is going to look like this. So at constant VCB of 0 volt, at constant VCB of 4 volt, we find VEB and corresponding value of IE. So we use we use a VEE to vary VEB. So let's quickly go into the Pro Tools simulation environment. I've already patched up the circuit, as you can see. So I've patched up the circuit. So let's start our experiment from a VCB of 0 volt. So VCB of 0 volt. We're starting from a VCB of 0 volt. So let's simulate. When VCB is equal to 0 volt, what is IE? What is our VEB? Everything is 0, 0, 0. So that is the starting point. As usual, like we did, when VEE is 0, VEB is 0, IE is 0. So when VEE is increased to 0.12, what is VEB? So we go to the experiment, we begin to iterate. At 0.12, VEB is 0.12, IE is still 0, so you record the value. So at 0, VEB is 0.12 and IE is 0 microamps. So we iterate again, we iterate the value by one more step. When VEE is equal to 0.24, VEB is equal to 0.24, IE is equal to 0.00. So we record the value again, 0.240, and we go to the next one. When we increase it to the next one, when VEE equals to 0.36, VEB is 0.36, IE is equal to 0.0. So no change yet. We record the value 0. So you go to the next one. So when VEE is increased to 0.48, VEB is 0.48, IE has now begun to move flow. That's the IE is now 0.57 microamps, 0.57 microamp, 0.48, 0.57 microamps. So 0.57 microamps. So when it is increased to 0.58, that is when VE is 0.6, VEB is 0.58, IE is equal to 23 points. Well, let's try to see whether we can reduce this value to 0.0. No, we are 0. So the highest we can get is minus 0.02, so it's almost the same thing as 0. So we take this reading. I is equal to 23.2, VEB is equal to 0.58. So 0.58, 23.2. What's the value of VEE that gave us that? The VE that gave us that is 0.6. So 23.2. So let's increase VEE again. When VEE is increased to 0.71, when VE is increased to 0.71, before we can take our reading, so we have to reset this to virtually 0. So I think 0.01 is the closest value to 0. So when VE is equal to 0.71, as we can see, our VEB is 0.61 and our IE is 101. So 0.71 at 0.71, what is our VEB and what is our IC? VEB is 0.61, the other one is 0.61, 101 microamps. Then we go to the next, we iterate again. When VE is equal to 0.83, so let's reset this to something around 0. Let's reset it to 0 before we continue the experiment. I think the lowest we can get is 0.04, which is still equivalent to 0. So when this one is 0.80, when VE is 0.83, our VEB is 0.63 and our IE is 196 microamp. 0.83, 0.63, 0.83, 83, 0.63, 183 microamps. Our IE is 183 microamps. 196, sorry, 196 microamps, 196 microamps. So when this is 0.94, let's see whether we can set this to, let me see, this one can be set to 0.15, 0.05. I think this is the lowest, because 0.1 is almost in the same vicinity with 0.0, so that's the lowest we can get there. So when VE is 0.94, our VEB equals to 0.64 and our IE is 296 microamps. 0.94, 0.64, 0.94, 0.64. Then what is our IE? Our IE is 296 microamps, 296 microamps. So let's take one or two more points, so we can now go to second point. So let's take when VEE equal to 1.05. When VE is 1.05, let's see the lowest we can get for. Can we get, okay, I think 0.16, 0.04 is still okay. So when this one is 1.05, our VEB is 0.65 and this IE is 398. So let's take note. 1.05, 0.65, 1.05, 0.65. Then what is our IE? IE is equal to 398 microamps. 398 microamps. That's a 1.05. 1.05. So let's take few more values before we plot the curve. 1.05. So let me take 1.16. Let's take 1.16. Let me just at 1.16. So let's see whether we can reset this value. Okay, 0.03 is the lowest we can get. So 1.16, 0.66, 500 microamps. 1.16, 0.06, 1.16, 0.66, 0.66, then 500 microamps. So let's stop here. Then we go to, so you should not forget we stop at 1.16. Then we go to VCB at 4 volts. So VCB at 4 volts. Let's set this to 0 first. VCB at 4 volts. We use this one to set this at 4 volts. At 4 volts. At 4 volts. Let's see. Okay, 3.96 is what we can get. So it has equivalence to our 4 volts. We begin to iterate. 3.96, 0.12, everything is 0. 0.12, everything is 0. 0.12, the IE is 0. Then at 0.24, at 0.24, at 0.24 is still 0. So at 0.24, 0.24 is still 0. 0.24 is still 0. then at 0.36, at 0.36, at 0.36 is still 0. IE is still 0, so the voltage is still 0.36, 0.36, 0.36, 0. Then at 0.48, at 0.48 everything is still 0. Okay, 0.48. let's see whether we can make this thing better. Okay, you can leave it there. So at 0.48 we have 0.48 and 0.61, 0.48, 0.48, 0.61, 0.61 microamps, 0.48, 0.61 microamps. Then the next one at 0.6, at 0.6, let's see whether we can set this again. 3.93, 0.007, 0.07, that's 3.93, 94, 95, 96, 97, 0.07. So let's see, 4.05 is more better. 4.05 is more close to 4. So 4.05 is more close to 4. So it's at 0.6 we get VEB to be 0.57, then the other one is 0.57 and 24.2. so this one will give us 0.57, 24.2, so 24.2, 0.57, 24.2. so let's iterate again. At 0.71 VEB is equal to 0.61 and it's 102, 0.61 and 102 microamps. So at 0.83, so let me adjust this, 3.96, 3.96 is the closest. At 0.83 this is 0.63 and 198, 0.63, 198. Then the next one, let's go to the next one at 0.94 VEE. VEB is 0. Okay, for taking the reading, let's make this thing close to 4. 3.95 is what we could get. So at VEE equals to 0.94, we have VEB to be equal to 0.64 and 298, 0.64 and 298, 0.64, 298. Remain 2 more points. So let's try to run the remaining 2. So at 1.05, let me adjust this thing to close to 4. Okay, at 1.05 VEB 0.65 and this one is 400, 0.65. this is 400 microamps. And the last but not the least, when this one goes to 1.15, let me adjust this. So when this one is 1.15, the value of the VEB is 0.65, VEB is 0.65 and the other one is 501, 0.65, 501 microamps. So with that, we can quickly plot our input characteristic curve by taking these 4 values. Take these 4 values, you go to your insert, click on graph, straight line graph. So this is what you will get. Now when you look at this graph, you see that it looks very much. Now the only thing is, if we had drawn more values, you can actually get this one rising too. But because of time, because I don't want the videos to be too unnecessarily large. So but I will suggest when you want to run the experiment on your own, try to create a time and run more values. You see this one rising at the second part. So this is going to be the curve. So this is even more better than the first one I did. You can see the first one I did was almost mobbed together, but this one, at least this one has shown a level that this one will rise, but at a later point it will rise. So that is that about that. So how you find the input character and the way to find the parameters, the same way you did the input parameter is the same way you're going to do the output parameters, just that at the output parameters, instead of you to be varying this to keep this K constant, you now keep IE constant, just like what we did in the output parameters, output characteristic of the common emitter. So I would suggest you try to do that on your own and try to get the values. If you run into any problem, please kindly let me know through your comment section, or you send me a mail on the email that is attached to this video, then in the email that is attached to this channel. I'll be so glad, I'll be more than glad enough to respond to every comment, because I appreciate your comment. I will appreciate your message. And if you have any questions as regard everything we've done, or any areas in electronics and electrical engineering, kindly reach out to me. Thank you very much. That will be all for now. Please kindly click the subscribe button if you have not done so already. Subscribe to my YouTube channel. Click on the notification to get more videos as they will be released. Thank you very much.